appreciate you taking time out of your busy day to attend this webinar. Hisco and Alpha had a long, very prosperous association in history. Hisco takes care of our customers for us by supplying our materials to our customers exactly when they need it. And when Hisco came to us and asked us to participate in this week-long seminar series, and for those that don't know, there's a different topic every day at the same time, 2 p.m. Eastern, we were delighted to do so. Today's webinar is Advanced Driver Systems, the Road to Autonomous Driving, and where Alpha fits in. Coming up on the schedule for tomorrow is troubleshooting the SMT and wave starter process. And then we have rounded out on Friday with Alpha's Lumet product portfolio for LED applications. We're going to introduce you to the basics of LED. We're going to talk about LED assembly hierarchy, levels 2 through 5, and identify those for you and tell you where Alpha's products fit into that. Today, again, we have Steve Brown, and I'll say a few words about Steve. Steve is the Director of OEM Marketing. He actually works for McDermott Performance Solutions, which is our parent company. Steve has been in the electronics industry for 21 years, and his job and his mission and purpose is driving growth in the automotive sector for Alpha. So that it basically includes all facets of how we approach automotive customers in the market, the products and the technologies that support that. He's worked for Lord Corporation, Cyberonics, and Celestica in his long storied career, and he has a degree in electronics manufacturing and engineering from Loughborough University of Technology, based in Woking, the UK. So from across the pond, I would like to welcome Steve Brown. And Steve, the platform is yours.
Thank you, Robert. Hopefully everyone can hear me okay. Right, so today's webinar, I'm going to go through everything in this presentation and then invite questions towards the end, at the end of the session. So anything you want to ask at the end or type into your computers, we'll pick up those questions and hopefully deal with them all at the end of this session. So I wanted to talk today about really the automotive market generally and some major trends that we see. And then really the main topic of this webinar is the route to autonomous driving. What are ADAS systems? What is the market looking like, and what is the overview? And then obviously to link that then into what the Alpha solutions that fit into the current and next generation ADAS systems. A few words on this before I start. It's all over the newspapers. It's all over the press, it's all over the media about the development of autonomous driving. And really what this means for anyone in the electronic supply chain is a number of very interesting, exciting growth opportunities, also a lot of fear and concern about the reliability and the safety of autonomous driving systems. So what I aim to do today is give you an appreciation of this market and how it's growing and which systems are key. And really how, as Alpha, we fit into this space as a supplier of materials for building electronics and electronic systems. So let's just start with some general automotive market and major trends to understand where we are with all these parts. I think many of you will know that in very round numbers, the world is now producing about just under 100 million vehicles per year. 90 million of that are passenger vehicles, light passenger vehicles, and about 10 million are heavy goods vehicles. And then if you look at some of the major brands in the world, both Volkswagen and Toyota are still pretty much the biggest manufacturers of vehicles, with approaching 8 to 10 million vehicles for each of those companies, so almost 10% of the market each. And actually the spread of those sales changes from region to region. For example, Volkswagen are very big in Europe and Asia, not so big in Americas, not so popular after their recent exploits on emissions. Toyota, not so big in Europe, but really big in Americas, and obviously very big in Asia, being a Japanese company. So really, typically what we're seeing is that if you look at the Americas, Europe and China, each of those singular markets doing about 20-ish million units each, and then you've got all the other parts of the world making up the rest of it. In fact, Europe and Americas is both very similar at about 22 million vehicles per year, and then China itself is actually a little bit more than that, and then we add Japan in with 10 million or so, and we get to our 100 million pretty quickly. Here's a closer look at the numbers. The 15 numbers are still not verified, but typically we're seeing about 23 million units of vehicles being built in the Americas, of which 17.5 million are in Canada, United States and Mexico. So most of the market is in the continent of North America. So why is that important? It's important because when we see the growth of some technologies such as auto brake or start-stop systems or cameras being mounted in different applications, it gives us a sense of what the market potential and how many units could be installed if there's 100% adoption or 50% adoption, etc. You can see down the bottom there, the estimate for this year is 94.5 million light vehicles, and then in total about just under 100. This then really shows, and this is from Prismark Partners, this really shows the spread of the vehicle makers and then the tier ones down the side, the tier one suppliers. I think, you know, hopefully everyone on the call is pretty close to the automotive business, but just in case, effectively a tier one supplier is anyone who builds any sort of product or module and delivers it to a car maker, an OEM, such as Ford or GM, delivers it to the factory, it's then installed into the system. So a tier one could be a steering wheel manufacturer, could be a seat manufacturer, it could be an ECU module manufacturer from an electronics point of view, or an infotainment system. And just give an overview of the spread there. And a couple of things to note really is what we're seeing over a period of time. This chart is now a little bit outdated, but what we're seeing over a period of time is most of the tier ones are operating across multiple OEMs. So most of them are working across many of them. A good example of some of the changes we've seen over the years is that Toyota group used to be very heavily reliant on Denso, and over time they've started to spread their production opportunities to quite a number of tier ones such as Continental and Bosch and Delphi as well. So what we're really seeing is, in terms of growth in electronics, really regulation drives a lot of growth in the United States, within the European Union, in Japan, in different places. And that really falls into, you know, three major categories. The first category being exhaust emissions, which, you know, it was a big scandal last year with how some of that was measured. Another area which is commonly focused upon is fuel efficiency. And the third area, which has a lot of regulation coming in, is to do with safety systems for cars in different regions. And what we see as a trend is if the United States legislates to do something, typically the European Union or China or everywhere else seems to follow sometime after, and vice versa. So most legislation tends to become quite global. So actually, if you look at the main drivers for electronics, these three things, they drive a lot of innovation in the automotive industry, the automotive electronics industry. And a good example of that, which is not for today's talk specifically, is that actually today, if you look at a mid-sized sedan, you typically, as much as 7% of the weight of that vehicle is in cables and harnesses interconnecting electronic systems. You know, a major manufacturer of cables, Lear Corporation, they pointed out in a Ford Fusion, modern Ford Fusion, it's somewhere between 90 and 100 kilograms of cables in a car which weighs about 1,500 kilograms, you know, giving us about 7%. So actually, as we put more and more electronics in cars and we join them together, we're actually adding more weight to vehicles, which actually causes problems in terms of fuel efficiency and makes it difficult to meet those standards. Safety is really dominated by technologies which move us towards ADAS, automated driving. That would be things like auto brake, lane departure warning, blind spot assist, etc., etc. And that's really what we're going to talk about through this webinar today. So really, when we're looking at our portfolio and what, as a wider company, you know, Alpha and its sister companies within McDermott Performance Solutions, we look at some of the major trends that are happening in the automotive industry, and we're always trying to understand how, you know, the supplier of electronic materials really fits into some of these major trends. So the first trend we see, as I touched on, is really the improvement of fuel economy in many areas, and there's actually strict targets on, you know, fuel economy targets for manufacturers in different regions. And one of the ways that people are looking to do that is to reduce the weight of electronic systems and interconnect. That never used to be a feature. The weight of electronics in cars never used to be of any significance. And as we've made many, many more systems, electrical, electronics, and electromechanical, the amount of these systems going into cars has become significant. So we're starting to see an increase in the use of printed conductors to replace cables, and people looking into how you can do that. People are starting to look at things like enabling the use of lower weight substrates. So, for example, let's go from rigid laminates to flexible laminates in many cases for interconnect in different areas. To enable the use of smaller form factor power devices, such as, you know, our Argomax technologies are really enabling the use of much smaller power semiconductors to switch major mechanical units, putting a lot of current through a very small space. All of these things add up to help improve fuel economy. And one of the things which is further out, the final point on this, is to see how you can include sensors and some different parts actually inside body plastics and some parts of cars. And a good example for that would be, if you look at radar, which has been introduced into many cars, there's a kind of clunky unit in the grille, which is kind of integrated, but you can tell it's a separate unit. And the way car manufacturers want to go to is, as much as possible, integrate a lot of these sensors and systems into the front fender and the rear fender of the car, so they become integral to the development of that vehicle. And that has big implications for us and for how we supply materials and what materials we need to supply in the future. Main topic for today, autonomous driving and safety. Really, one of the things became very clear in the last couple of years on this is, if you think about really what a lot of autonomous driving is about the automation of braking and steering and the control of the actual vehicle. There's a lot of fear about this as well. You will have all read about the Google car and the Tesla crash and different things. The reality is that humans make a lot of errors when they're driving cars, and that's kind of accepted, and things happen, and people fall asleep at the wheel and forget to press the brake and go into cars in front of them. The moment you automate those systems, the expectation as humans is to have zero failures whatsoever, and you know, it's a big story when any of these systems cause failures, and that's why the Google story, the crash into the bendy bus was an issue, and the recent Tesla issue as well. So actually, from an opportunity point of view, as people building hardware, building electronic systems, they're really, really looking more and more for the highest reliability interconnect materials and processes. You know, there's the possibility for these systems to fail is disastrous. We're also looking for more miniaturization and integration possibilities. You know, more and more of these sensors we're building into a car, you know, again, are adding more weight, as we touched before, and to try to integrate them more closely and integrate them seamlessly into the vehicle becomes a major focus for automotive manufacturers. Major trend 3 is all about assembly cost and efficiency, and I'm not going to spend any time on this slide except to say, if we look at many of our Tier 1 customers, one of their aims is to not supply multiples of different electronic modules which are joined together, but to try and offer a more complete package. And a good example of that was people developing center stack electronics. In the past, it was a panel with some buttons which stick through, with some electronics which are joined together behind with some cables. More and more companies are trying to develop systems where they develop a complete center stack or a more complete center stack to the car manufacturer, which includes multiple functions from infotainment to HVAC and all the instrumentation cluster as well. And then the fourth major trend really is increased connectivity. This is becoming really, really big, and this is a big part actually of fits into ADAS as well. Really, connectivity, we used to just think of the Bluetooth connection from our phone to our car speaker system to be able to make calls. But a lot of it now is to do with safety. This is vehicle-to-vehicle and vehicle-to-cloud networks, which is becoming a very big subject and a big area about how you stream traffic information and rerouting information and safety information, frankly, from the cloud and from different vehicles as well, from one vehicle to the next. So there's a lot of discussion at the moment about a lot of infrastructure which will be built over the next 10 to 15 years of on-highway systems, giving information to cars as they pass, and actually feeding back from cars onto those systems about traffic density and everything. But really the key thing for this is the software and hardware reliability becomes critical. If any of these systems fail, it becomes a real challenge and a real problem in the system. So I've now got some slides which I want to talk through specifically to do with ADAS and the focus of today's presentation. So really, without talking through all the words on this, really, if you look at what ADAS are, they are systems, integrated systems to automate, adapt, enhance vehicle systems for two reasons, really. For both improving driving experience, but also to improve safety. And I think, people sometimes look at ADAS and think maybe this is something that's going to come in the future, or this is on a future car. Actually, it's coming at us now. It's in many cars already. People are launching cars with auto brake functions and a number of different systems. And I'll talk you through some of the jargon and some of the terminology within this system at the moment as well. It's key to say that ADAS, Advanced Driver Assist Systems, is the fastest growing area of automotive electronics. And in the initial stages when people started looking at, they were really thinking about just the sensors, but actually the amount of computing power through the ECUs, the electronic control units, and the amount of integrated systems to help with steering and braking actually make this a very, very big area to focus on in the future. Really, currently most of these systems are built within the car, so they're based on vision and camera systems and sensors such as radar and LiDAR, etc., etc. But over time, what people are seeing is more and more vehicle-to-vehicle information systems and vehicle-to-infrastructure, which is pretty big. And what you can see now on this image here is that we've been very used for quite some time for a number of very basic ADAS systems, such as parking sensors that have been around for in excess of 20 years. All the way through to the last 5 years, we start to see things like lane departure warning systems. And then we're getting into some of the active cruise control systems, which have things like auto braking functions included in them as well. So really, ADAS is not one thing, it's multiple of systems which are there to move us towards automated driving. This graphic here just shows a number of those systems which would all come into, would all knit together to make part of the ADAS experience. Adaptive cruise control, is something, a real advancement for people who do a lot of highway, motorway driving, in that what ADAS does is it uses a number of radar technology to keep the distance between the car in front beyond a certain level, so you don't get too close to the car in front. And actually, if you go in a car with adaptive cruise control, it's kind of a bit frightening at first because it will automatically slow down when it gets too close to the car in front, and more interestingly, it will speed back up to the set cruise control speed when the gap becomes big enough as well. So adaptive cruise control includes, an element of automated braking within the system. A lot of concern about whether that system fails and what damage that could cause, loss of life, and the amount of liability based on the car makers and the system makers. Second one here is lane departure warning. Lane departure warning has come through several generations. It's been around for quite some years now, since the middle of the last decade, commercially. The initial systems were developed mostly for heavy goods vehicles, The concern was the heavy goods vehicle driver on a very long journey would possibly be falling asleep and dozing off, and this system would be tracking the sides of the road or the lane the driver is in. And if the vehicle veers to one side or the other, and the system thinks it's not on purpose, it's not flicked the indicator switch, for example, to change lanes, then it would alert the driver. And the first generation was just a warning, a vibration in the seat or some sort of audible warning on that system. But the second generation is really where things got pretty interesting, because it actually developed, it would actually move the steering wheel to reposition the vehicle into the middle of the lane. So there's some active steering built into that point at that stage as well now. That feeds into something called lane keep assist. And lane keep assist is a system which Tesla have in their vehicles, and a number of new generation vehicles is becoming standard, something which keeps the vehicle right in the middle of the lane so you don't drift from one side to another. Again, it's the automation of steering. And then there's some more passive type systems like blind spot detection, where you get a warning to say there's a car to your side when you're about to pull in. Park assist has become quite common in many systems. This is less worry about park assist systems, because this is something done at low speed, unlike lane departure warning and adaptive cruise control. And then you get some other systems such as night vision. And you can see at the bottom of this, these companies who are promoting some of these technologies are customers which you probably know, like Continental, Autoliv, and Bosch. So actually, if we look at what ADAS, how does ADAS work? It's effectively a network of vision and sensors. There's long-range radar, there's LiDAR, which stands for light detection and ranging. There's a range of cameras, there's some short and medium range radar, and there's ultrasound for park assist type systems. The key thing is that actually none of these sensor, vision or sensing technology on their own is good enough to do all of the functions we need to do. So these multiple systems knit together make very rapid decisions on what should be activated, what should happen with regard to steering or braking or some of these different things. So actually the amount of processing power and the speed of that processing becomes very critical, because these systems and what they're detecting have to make split-second decisions on what to do, whether it should activate the brake, whether it should readjust the steering, and all of these different parts. So while it's kind of interesting, while it's something which the technology is moving at a very rapid rate, there's a massive amount of concern within the industry about the reliability of these systems and how they would actually come in, because as we move further into ADAS, we're going to become more and more reliant on these systems as we become comfortable with them. And really, if you look at, and there's a few slides on this really on how the terminology happens within ADAS. Really, we started back in 1958 with cruise control, which was really to do with safety and convenience to a degree. And then the seatbelt reminders in the 70s and airbags in 1973. I'm not going to go through every one here. And then in 2000 to present, we're in the sort of current ADAS systems of things like rear cameras, park assist, adaptive front lights, helping us to see around, as we go around the corner, the light moves with us, auto parking, blind spot detection. And now we're moving into, and we're getting into the stage right now in 2016 where we go to this partly or partially autonomous. And many cities in the world are piloting these cars and systems to see how safe they are. And that's why all the time we're going to see newspaper stories about what's actually happening on some of those areas. Autopilot from Tesla is probably one of the most well-known systems that people are talking about at this moment in time. And then as we go further on, we are going to get to a stage with full autonomy. Whether people like it or not, that's the direction we're going. How it's legislated and how governments put in systems to ensure these systems are working properly and meet the requirements and requirements of any country is a big topic of concern, and there's probably a conference every week somewhere in the world on this subject itself at the moment. So really people are using this terminology now of level 0 to level 4. And so what I've found is that, you know, level 4 is where we're going to get to, and then level 5 is when you get to this full automation. This just gives an overview of some of those different systems. And actually, if you look at where we are today, really we're pretty much towards level 3. Level 3 is kind of available in many ways. Level 4 is kind of being tested. People are pretty uncomfortable with urban driving levels of automation. There's an increasing level of acceptance of highway driving in relatively low traffic conditions, but a lot of testing is happening throughout the world. But this is really when people say we're developing level 4 systems or level 5 systems. This is what they need. And the only reason why these levels have been developed is really because people were trying to use the same language of what section a car would get into. In any of these conferences that you may go to, you get people talking about these different levels, and it started to become a fairly common language. This is a busy slide here, and I'm not going to go through every single point here, but just going through from left, I'll just go around the different areas. But the general market really, and these market numbers don't mean a lot to us all the time. When they say the market will reach 60 billion by 2020, that means that the value of systems sold by Tier 1 suppliers to the car makers would reach that level. So when they sell a box of tricks with radar and different things to Ford, that sales value adds up to 60 billion by 2020. But the key is it is growing at above 20% a year, and that's why companies like Bosch and Valeo and Delphi and Autoliv are investing a lot of money in these systems at the moment as well, because there's a lot of growth. From a material supplier point of view, why is that interesting? Well, if you get products specified on a number of these different modules, you know, you would expect to see, you know, a very considerable volume growth over the next 5 to 10 years. Then really, if you look at the total percentage share of the system by type and segment, it just comes through some of the different systems within there, different areas. And then going down on the bottom left-hand side, by the sensor types, really what we're seeing now is radar is the biggest sensor type we're seeing in the systems. But radar does have its limits, and me and some of my colleagues were being involved in a number of projects recently about talking about things, even about the best PCB surface finish, for example, for some of these radar sensors, and some concerns about some different finishes and how they would fit in there. But what we would expect to see is a growth in things like LiDAR, which is better in a number of different weather type conditions, and a massive increase in terms of some of the laser sensors as well that would come in there. In terms of the markets by geography, by size, Europe is probably by some way one of the largest areas at the moment, but North America is coming up very quickly as well in that area by the installation of a number of different technologies. And a lot of that is driven by legislation a lot of the time. So the inclusion of lane departure warning systems, for example, on heavy goods vehicles is, you know, only 5% of the vehicle market, but actually the hope from most manufacturers is that will flow down to passenger vehicles over a period of time. So the heavy goods vehicles market is interesting, but actually it's nowhere near as interesting as the passenger vehicles market, which is much, much bigger. So if you look at the areas here, when we look at the market growth, 2012 to 2017, this is now a few years old, this is automotive electronics in total. If you actually look at lighting, powertrain, which includes a lot of the chassis systems, so ECUs that go under the hood, and anything to do with braking and steering, really encompass part of that ADAS area. And what we're seeing in there is an increasing technology focus in solder technologies, you know, the physical reliability of these systems, the hardware reliability. Most people know that if you're building any sort of hardware system, mostly it's the interconnects which are the point which you're going to possibly see a significant amount of those failures, especially when you have electronics going into high temperature, high vibration environments. The the materials and the material sets and the correct materials become quite critical for making sure you've got a reliable system that can operate over many, many miles in pretty harsh conditions. The fourth point on here is really what we're seeing is greater electronics content per vehicle, which I touched on before as well. So it's really powering a lot of our growth at the moment is through this ADAS area. So in addition to regulation generally, what we're seeing now is a lot of legislation, a lot of legislative points coming through over a period of time. And I'm not going to go through most of this, but it comes down to things like NCAP, some of the crash prevention areas, and legislation really drives a lot of the things which we see coming forward. So we try to keep an eye on what's going to come through in different areas and how that impacts our business as well. This is really where people are, very concerned really about, if we do automate a lot of these functions, can we get to the stage of seeing completely accident-free vehicles? And there's a lot of statistics already out showing that ADAS technology has a very significant effect on reducing the number of accidents. But accidents are not ever going to be eliminated completely. But really one of the problems then comes in is if Steve Brown's driving up the road and he forgets to press the brake and hits the car in front, then it's my fault. My insurance has to pay. It really is my issue. At the moment you automate those things, the concern is that where does the blame lie? Does it blame with the car maker? Does it lie with the tier 1 manufacturer? Does it even go further down the chain? So there's a lot of concern, a lot of discussion on these things at the moment. There's a high degree of dependence on electronics and sensors to operate the vehicle. So this becomes a really big part of this whole jigsaw and this whole jigsaw of automated driving. But manufacturers push back at the moment as they can't afford costly liability claims and warranty failures. And recalls for safety systems. They have to absolutely make sure these systems are super reliable. And that really we're starting to see as a major focus area in a number of these different areas. If you look here on the graph on the right side was something presented at a conference a while ago, and it was seen that the percentage difference in crash rates from a number of studies, and it was done by Fiat Chrysler, by Honda Accord, on a Mercedes study, a Volvo. And what it typically saw was that if you had a warning-only system, i.e. an audible warning or something which warned the driver of a problem, you saw sometimes some effect, sometimes it had no effect whatsoever. Maybe the warning wasn't loud enough in some of those areas. But actually, if you then went to a warning with some sort of auto brake, in most cases there was a significant decrease in the amount of crashes. The problem with the data at the moment is, one, there's not enough of this data, and that's why the stories are always coming round and there's always in the press in different areas. And there's a lot of concern from the government level that different governments, that the lack of this data makes them nervous to try to allow a lot of this automated driving functions to become allowable in, for example, urban type areas. If you go to any of these companies now and you look at these areas, these are probably the top 20 companies that keep coming up as suppliers into the ADAS arena, and some of them are semiconductor manufacturers and some of them are actually tier 1 system manufacturers as well. Now this list of top 20 will change over time, and it's very much a shifting sand at the moment, but if you go into the websites of companies like Bosch or Continental, for example, or Autoliv is a classic one, there's a lot of information on these ADAS systems and how they come together. What we've added here now is just a glossary of terms, some of the different terms they use in the ADAS world. When we started to get involved in this a while ago, we went to a few conferences and actually, people were talking almost a different language. We were trying to understand, what they were talking about with some of these things. Some of it was obvious, like ABS, anti-lock brake systems. We all kind of knew that. And then things like LKA was kind of new to me 18 months ago, lane keep assist. So there's a number of these different areas which are coming through over time. So, where does a company like Alpha fit into ADAS, and where does this all come through? And I've given quite a few hints already, really. You know, ultimately the concern with ADAS is about its ultimately system reliability and how well will the system work. And really, when you look at most published work on this, there's two areas to that system reliability. There's the software functionality. Can it make the decisions quick enough to take an action, to apply the brake or move the steering, or many different things. And then there's the hardware reliability, and this is really where the material sets start to become quite critical. So people are very concerned about, for example, on a electronic braking module, which is going into areas which gets very, very hot. Is it able to perform reliably and operate seamlessly every time when it's in an automated system, not relying on the driver to press the brake pedal? Can that do that automatically? And really, from a solder's point of view, this really comes down in many ways to do the operating environment of electronics. What we find is that when you put electronics into a fairly benign environment, such as a TV which goes into your home, you know, it sees a very small temperature swings over time. It sees a pretty safe environment. It doesn't see any vibration. But actually, when we go into the car, we're seeing more and more electronics going closer to the point of use. So closer to the engine, closer to transmission, closer to the wheels, in all different areas. And as we're putting more and more electronics in cars, that becomes inevitable. What we typically see is that if you go to areas such as on engine and on transmission, or pretty much close to the engine manifold, very close to the engine, under the hood, near to the engine, all these different areas, we're seeing typical operating temperatures of 120 degrees and above. And we're actually seeing quite high levels of vibration as well. And once we get to these levels, that's really when we have to go beyond our standard materials and the standard tin, silver, copper, SAC 305 alloys, because frankly, what will happen is that under the vibration and heat, you'll see quite early life failures of those solder joints. The danger then, of course, you get a failed solder joint, you may get an intermittent failure initially, and you'll start to get to a point where you can have failure of the actual system to operate. So first, the operating temperature of the electronics becomes very, very key. You then look at things like vision and detection systems, cameras, radar, sensors, all these different parts. They become a critical part of this network of systems. And when you've got a vision or detection system which is there as a passive aid or something to give some sort of information to the driver or warning, that's one level of automation, as we talked before. But as you move up to level 3 and level 4 of ADAS, it becomes much more critical. So really, you know, if you look at our focus areas and our products, and some of the other webinars during the week go more into product detail, this is really where fine feature assembly becomes very, very key. So the integration of cameras into different parts of the car means that you're actually using some camera technologies which have come from the mobile phone type industry, the cell phone industry. Very fine feature chip scale packages, 0.5 millimeter pitch between the balls and moving towards 0.4 millimeter pitch as well. And then they've got to go into an environment which sees a lot of heat and vibration. So the development of the most robust electrochemically migration resistant chemistries become very key, and the use of alloys which can withstand these temperatures become very key. And then from a die attach point of view, a lot of these sensors go through a die attach process and really has a number of materials there, such as silver sinter type technologies, silver loaded adhesive technologies in Atrox, and some preform solutions for actually joining some of these different materials. So one thing we try to do in all of these conversations with the big players in this area, and two examples would be companies like Valeo or ZFTRW, is to talk to them about exactly the operating environment which the product goes into, what temperatures it's likely to see, how much vibration it's likely to see, and that pushes us then towards, you know, which product systems we would like to recommend for that application. Then we look at things like braking and steering electronics, very much sitting under the hood, many of these electronics. As I said 2 slides ago, they're seeing operating temperatures which are actually increasing over time because of the location of the electronics and where they're actually going. So the key to them making them super reliable is having a number of different systems which will fit into that. So power semiconductor die attach becomes absolutely critical. We're getting smaller semiconductors with higher current densities running through them, so their junction temperatures get very high. So a number of the materials which will join them together become very, very key. Again, we've got the Interlot alloys, Maxrel, which is an alpha-specific alloy for PCB assembly for some of this area. And then also one thing to focus on is how people are looking towards wave elimination for connectors on some of these modules. And one of the big trends we're starting to see is most of our automotive customers are moving away from using wave solder and even selective solder for some of their connectors. And part of the reason for that is that as they've gone to selective solder, they've tried to find more efficient ways of assembly. Some of the industry has gone towards press fit, but not in the underhood arena. Certainly for the in-cabin type electronics, press fit has become somewhat popular in some less critical areas, but solder is still the interconnection method of choice for connectors in the underhood area. So one of the ways that we can move towards that is to use of the paste in hole printing of the paste. We print the paste over the hole, the use of preforms to add volume of solder to those deposits to get a very consistent through-hole fill consistency. That reduces stress on the PCB laminate, and the major reason why most automotive companies for high reliability are going there is to actually reduce the number of potential electrochemical failures caused by over-application of liquid fluxes in areas that may not see much heat during the process. That becomes very, very key. So finally, what I want to talk through here is the thought shift, and really to try to crystallize some of the things which I've talked about in the last 40 or so minutes. And it's really to do with the automotive warranty and liability over time, and driverless cars or automated driving are really forcing the thought shift in this area. There's a growing general consensus that liability will shift from the operator, me or you driving your car, to the manufacturer, with that emphasis on product liability. And this is really interesting because the focus on system reliability and hardware reliability, really comes to the top of the tree again. However, most people are pushing back on this. They're saying that drivers and occupants will have to carry some liability due to misuse of the vehicle and that sort of technology. But an extreme outlook is the OEM responsibility could go from 2%, most crashes are blamed on the driver, to somewhere between 80 and 100%. And this is a massive subject of area of focus at the moment for the automotive industry. Some of the questions that have come through: does the OEM, the car maker, become the insurer for the vehicle? What does that mean to product liability issues? And how to determine who's at fault? Is it the driver, the vehicle itself? If the car drives itself into a tree? Is it to do with software updates? Is it to do with aftermarket additions such as hacking? So one thing we're seeing a potential growth in as well is that there's a growing call for a mandate that all cars would have data recorders, black boxes in there, to actually record what happens and what would happen in the event of a crash. Looking through all of this, the real key to alpha, to material suppliers and PCB suppliers and component suppliers, is that the electronic hardware and software reliability have become much more critical than they ever have before. So that's the end of my presentation. Hopefully it was a quick run through ADAS, some of the implications for alpha and for material suppliers in general. It's an area we're seeing growing rapidly and becoming such a big part of the growth area of many of our customers. So it's quite often coming up as the area that they want to have most interest in, and they're seeing most concerns about, frankly, about how can they make systems more and more robust. So with that, I'll pass it to the floor to any questions from there. Thank you.
Great job, Steve. Thank you. So again, any questions from the floor, please jump in. And then Dave, if there's any typed questions, maybe you could moderate and read those.
I have a question. Has the unique demands of the automotive manufacturers led or is leading to any new product development from Alpha?
Yeah, absolutely. The main areas of focus are to make more robust systems, actually. So if you look at what does that mean, there's really two parts to that. One is the electrochemical performance, so making a number of our materials which are able to meet and exceed the requirements to do with damp heat testing and a number of very harsh environment conditions. So that's developed towards, further develop these sort of zero halogen chemistries with very strong resin matrices to give very high SIR performance, and that becomes quite critical. And that really is the main driver for the move away, which we're seeing, which is a potential threat to us, but the big move away from wave and selective in this area is because these sort of low solid fluxes, which a lot of these products don't necessarily see all of the heat they should do. The flux out of a cord wire or a solder paste naturally sees a lot of heat to actually physically melt the solder and form the joint. The danger with some of the wave solder parts is that you can put flux anywhere, and maybe it spreads to an area, it causes a problem. The second part of it, of course, is alloy development. Alloy development is something which we didn't really see 10 years ago would really come and be a major portion of Alpha's development. Alpha Metals, as we were called many years ago, was a metals company. Then if you look at the progression, people started using just generic solder alloys for many things. What we've seen is that the automotive industry has almost universally adopted the SAC 305 or SAC 387, but the tin, silver, copper 3-part alloy. And now what it's finding in these more extreme environments which are putting electronics into, that actually SAC 305 or SAC 387 is physically not good enough. So, we've been on a number of developments, and the most prominent one, which was an industry development with a few suppliers, was the Interlock program. And now there's further development from then into the future of other materials which are very heat and vibration resistant and crack fatigue resistance. That's the main part. The second development really is to do with sinter technology, which is the Argomax product line, which is a way of attaching semiconductor die to base plates with materials which can operate at very, very high temperatures, beyond that of tin-based solders. So we provide a nano silver material which sinters or diffuses into the substrate and into the semiconductor to produce a very, very strong bond that can operate at temperatures above 175 degrees C, which no solders can actually do. So it's very much been driven by the areas, the environment which the electronics go into, heat and vibration being two very key attributes there. But the other one that's coming back to us now again is miniaturization as well. So miniaturization is automotive electronics used to be just big and chunky and robust, and now it needs to be robust, but it needs to be miniaturized as well to reduce vehicle weight, etc. So it's driving us in both directions, which is a difficult challenge because as you miniaturize things and make solder joints smaller, intuitively, there's a risk of making them not as strong and not as robust. So that's why alloy development has become quite key as well.
Okay, thank you. That's all the questions that have been chatted.
Okay.
Okay.
Thank you all.
I'll wrap things up. Steve, again, thank you for your time today. It's certainly great information, presented extremely well. To our customers that were on today, on behalf of HISCO, again, my name is Robert Wallace. I'm with Alpha. we certainly would like to thank you for your time. You will be getting an email in the next couple days from HISCO, and on that email is going to have a ebook of relevant technical papers related to automotive, some of the white papers that we've published here recently. So be on the lookout for that. We would encourage you to visit the HISCO website and to register if you haven't done so already for the remaining webinars in the series coming up. Again, tomorrow, Thursday, troubleshooting the SMT and wave starter process, and then on Friday we wrap it up with Alpha Lumet product portfolio for LED applications. So that would conclude the proceedings for today. Again, thank you for your time. If there's any other questions you think of in the meantime, I believe you have my email address on the link, as well as Steve Brown and Steve Dowds' email. Please don't hesitate to reach out to us, and we certainly will get your questions answered. So on behalf of HISCO, thank you, and that would conclude today's proceedings.
Thank you.